Ninja Warriors, today's session is going to be all about case study session. So if I'm audible and visible, do let me know in the chat box. Okay, alright. Yes, Anonymous, application of derivative and differential equation. I'll be taking in today's session only. 5 o'clock, I recorded it, but the audio was gone in that video, so I need to redo it. So today, 5 o'clock, we are going to do application of integration, definite integration. Then we have matrices, determinant, relation, function and ITF. Okay, alright. Yes, audible. Alright, let's start. My voice has become very husky. I'm taking sessions back to back. That is why my voice has become something else. And I'm liking this voice. Okay. Alright. So let's start. Okay. If I'm audible and visible. Alright. Also, do like the session right away because we are getting into the session without any time. Okay, without wasting any time. Let me just put this session details on the Telegram. Okay, case study based session happening now. Okay, okay. My Telegram is also not working. My phone is not working. The phone has stopped working. No, not working. Oops, let it be. Okay, I have Telegram logged in over here also. Let me write case study based session happening now. Okay, alright. Okay, so let's start today's session without wasting any time now. So case study based session, 3 case study based questions will be there, 4 marks each. That is going to be 12 marks. Okay, this is the format of 2025. Let's quickly start one by one. So this is case study based question number 1, which is by the way from application of derivatives. Let me tell you one thing, that you guys are scared of case study based question, right? How many of you are scared of case study based question? Because see, big paragraph they are writing, but actually when you see, you need to read the paragraph at least twice, okay? So read every paragraph of case study twice, because otherwise you won't be able to understand. In fact, I also had to read each and every paragraph twice to understand it, okay? Although once you understand it, the mathematics behind the case study questions is not that difficult, okay? The only thing is understanding of this. Okay, so one by one, line by line we are going to read. That is the whole soul drill to decode the case study based question. So Ramesh, the owner of a sweet selling shop, purchased some rectangular cardboard sheets of dimension 25 by 40 centimeter. Okay, line by line. Do not rush in reading. Understand this. So now Ramesh is an owner of sweet selling shop. He has purchased some rectangular cardboard sheets of dimension 25 by 40. Okay ma'am, till now it is clear. But why is he purchasing? Understand. To make container packets without top. What does that mean? Chalo, this part ma'am we did not understand. So with this sheet he is doing something. He is making some container packets. How come he is making? Let's understand. Let x be the centimeter. Let x centimeter be the length of side of a square to be cut off from each corner to give that the shape of container. Now I am understanding. So basically there is a rectangular sheet. Okay. So 25 and 40. Let's draw the diagram and understand how is he making the container without top. Okay. Now from each corner, Ramesh is cutting square of x centimeter. So this is what he is cutting, this is what he is cutting, this is what he is cutting, this is what he is cutting. So basically if I talk about this, So the sheet now will look like this. So this will not be there. This portion will not be there. Okay. So this portion will not be there. This portion will not be there. What does that mean? Your sheet will look like this. Okay. Like this and like this. Understanding? This is actually a square of x. Square of x unit, square of x, square of x. Okay. So this we are cancelling it. If we are cutting it, so your cardboard will look like this. And now understand, if I fold this sheet just like this. So if I fold this sheet just like this and just like this, so it will become what? A carton-like figure will be formed. So a card, like a cuboid will get formed, right? A cuboid will get formed. A cuboid will get formed. Yes or no? A cuboid will get formed. And the top of the cuboid is not available. The top is not available, so this is how it will look. The top will be not available. So now did you understand? Okay. So now understand what is happening. So 40. This is your x, this is your x. So this length is 40 minus 2x. Correct? If I talk about this, so just understand what is this. So this is 25 minus 2x. Okay, 25 minus 2x. And what about this? So this is 25 minus 2x. Hold on. This is 25 minus 2x. And this length is x. So this is the cuboid. One length will be 45 minus 2x. One length will be 25 minus 2x. Other length will be x. So now the container has become a cuboid. Okay. Now we need to answer the following question. Now the question has become very, very easy. Find the volume of container as a function of x only. So volume of a cuboid, can anybody tell me? Ma'am, length into breadth into height. So volume as a function of x. Okay, solution to this is what? X into 25 minus 2x multiply 40 minus 2x. Okay, this is volume as a function of x. Now dv by dx, part number 2. This is part number 1. Part number 2, dv by dx. So for dv by dx, what should I do? So first of all, v of x, let's calculate. X is there, correct? This is what? 2 2s are 4x square and 25 into 40 will be what? So 25 into 400,000. So plus 1000 will be there. And this is minus 50 minus 80, so minus 130x. Correct? Now dv by dx. dv by dx. Let me calculate it over here. dv by dx will be what? So ma'am, 4x cube hai. So 12x square minus 260x. Okay, and then this is 1000. So 1000x plus 1000. This is your answer. Okay, so first and second clear. 1 mark, clear. Okay, so this is how it is. Let me just give you a brief. This is your volume. Do not forget to write centimeter cube. Unit will make a difference. Cubic cube should be there. Okay, let me just open. Your chat is not visible. Your chat is not visible. Please wear mic. Let me just wear mic because I don't know. Okay. Better, I think the voice is better. Kya? So this is volume. If you multiply it, you will get dv by dx will be this. Okay, so you can multiply it. Now as per the, now this is the all three questions, right? So this is the second, dv by dx. Third question, ma'am, third question. So third question is having choice. Okay, for what values of x the volume of each container is maximum? They are talking about application of derivatives. Remember, local maximum, critical point, double derivative test. So now you have dv by dx. dv by dx is 12x square. dv by dx is what? Tell me. 12x square. Okay. 12x square minus 260x. I hope I have not committed any calculation mistake, okay? And plus 1000. This is your dv by dx. Now you have to make your dv by dx equals to 0. Make your dv by dx equals to 0. So the moment you make your dv by dx equals to 0, x equals to 5 and 50 by 3. So you are going to get x equals to 5 and x equals to 50 by 3. Yes, split this, you will get it. Okay, x equals to 5, x equals to 50 by 3 if you solve this equation. Correct? Let's take this out now. dv by dx, let me just tell you that let's take 4 out of this. Okay, 4. So 4 will be there, 3x square minus 130 ka half will be 65x and plus 250 equals to 0. So 4 times this is what? 3x minus 50 and x minus 5 equals to 0. So from here you will get these 2 points. These 2 are critical points, correct? Now one value will give you maximum value, okay, and another value will give you minimum value. But how will we check? X equals to 5 maximum or x equals to 50 by 3 maximum? Okay, so now we are going to double differentiate. d2v by dx square is equals to what? Okay, so ma'am, from here also you can check 24x minus 260. Okay, so if you put 5 over here, so obviously you are going to get negative sign. So at x equals to 5, v double dash x is negative. That means local maximum. So that means you are going to get local maximum for what value of x? At x equals to 5, you are going to get local maximum. Okay, clear? All right, at x equals to 5. So we are getting a maximum at x equals to 5. Okay, ma'am, clear. Now, or check whether v has a point of inflection at 65 by 6 or not. So, you know what? How to check point of inflection? Point of inflection means double derivative should be equals to 0. Okay, double derivative should be equal to 0. If double derivative is 0, so just understand when double derivative, so v double dash x is 0, that means 24x minus 260 should be 0. Correct? So x is 260 by 24, that is 65 by 6. That means yes, v has a point of inflection at x equals to 65. Okay, clear? Perfect. Yesterday class notes, I tried to share, but it was not getting shared. The file is so big. Okay, so I have asked my team to make a compressed version of it. I'm going to share it like right after the case study based session. I have just pinged them. Okay. Why are you saying low voice? Low voice. So I'm going to change then. Change my mic. Okay. So if I change my mic, I am going to sound like this. Is it better? Is it better then? Good afternoon, Harshat. Okay. And let me check whether you're liking the session or not. How 25 minus 2x you guys are saying? 25 minus 2x. How 25 minus 2x? One student is asking, okay? So 25 minus 2x. Understand this whole length is 25. If you are cutting x from here and from here. So this is whole is 25 now. And if you cut 2x, so only this much part is left. Okay, only this much part is left. Can you see this is your base? This is your rectangular base. And these will be flaps. These will be flaps, carton, right? Remember this. So this is the figure and this will be flaps, not this. Okay, so if you just close it, you will get the figure. Okay, so imagination, let us apply a little bit imagination. Case study base number 2. Now this is a question from probability. Okay, probability. Okay, so probability. Now can you see big question, big passage? You need to have some patience to decode this question. Okay, probability questions are usually not very like straightforward. It will take some time to understand what is happening. Okay, so have some patience, otherwise we won't be able to understand. So that is why case study based problems need some time. Okay, alright. Arka bought 2 cages of birds. Cage 1 contains 5 parrots and 1 owl. Cage 2 contains 6 parrots. Okay. So what is happening? This is your cage 1. This is how a cage looks like. Cage 2. Okay. So this is 5 parrots plus 1 owl. Here 6 parrots. Okay. This is cage 1, cage 2. Now what is happening? One day Arka forgot to lock both cages and 2 birds flew from cage 1 to cage 2 simultaneously. Then 2 birds flew back from cage 2 to cage 1 simultaneously. Now understand what is happening. Understand. So from this is cage number 1, C1, and this is C2. In the very beginning, what happened? From cage number 1, 2 birds flew away. Okay. So now here there were 6 birds. So now there are 4 birds. Okay. So after the first transfer, what is happening? 4 birds here and 8 birds here. Okay. Then what is happening? In second round, 2 birds out of 8 flew from here to here. Okay, so round number 1, round number 2, this is what is happening. Now on the basis of this scenario, answer the following questions. Slowly you have to read. Okay, when 2 birds flew from cage 1 to cage 2 and 2 birds flew from cage 2 to cage 1, then find the probability that the owl is still in the cage 1. This is a big question we need to think. Owl is still in the cage 1. Okay. So, understand. What are the possible cases? Understand. Round 1. So, round 1 mein 2 birds flew away. 5 parrots plus 1 owl initially. Okay. Now, 2 birds are transferring. Okay. So, what is happening? There may be a case. Case number 1. Case 1. Case 1. That initially 5 parrot, 1 owl. So 2 parrots flew away. 2 parrots flew from 1 to 2. Okay. Alright. 2 parrots flew away from 1 to 2. And then 2 parrots came back. From 2 to 1. This is round 1, okay, and this is round number 2, okay, case number 2, that this time 1 parrot and 1 owl, okay, 1 parrot and 1 owl flew from 1 to 2 and what is happening now? 1 parrot and 1 owl is coming back from 1 to 2. Case number 3. 1 parrot and 1 owl from 1 to 2 and at this now next turn pe round number 2 mein. Okay, so this is round 1. This is round 2. Again this is round number 1. And in round number 2 this time 2 parrots came back. Okay. Understanding my point? Only these cases are possible, yes or no? Case 1, case 2, case 3. Let me explain one more time. Initially this is cage number 1, this is cage number 2, correct? 5 parrot, 1 owl initially. So in the first round 2 parrots, that means owl remains same. 2 parrots flew from 1 to 2 and 2 parrots came back. Okay. So after this case number 1, just tell me what is the condition of cage 1 and cage 2 now? So condition of cage 1 and cage 2 will be the same. 5 parrot, 1 owl and 6 parrots. Okay, there is no change in the configuration of cage 1 and cage 2. Okay. Alright ma'am. Now case number 2 can be what? 1 parrot, 1 owl flew from 1 to 2. And what is happening? 1 parrot, 1 owl is coming back. Here also what is happening? There is no change. Okay. So still 5 parrot and 1 owl in cage number 1 and 6 parrot in cage number 2. But can you see case 3? 1 parrot, 1 owl flew back to 1 from 1 to 2. Okay. 1 parrot, 1 owl. But when it comes to coming, 2 parrots came back. That means now what is happening? Your cage 1 is having 6 parrots and cage 2 is having 5 parrot, 1 owl. This is what you need to understand. These are the 3 cases. Now as per the question, when 2 birds flew from cage 1 to cage 2, 2 birds, okay, then probability that owl is still in cage 1. Probability that owl is still in cage 1. So probability that owl is still in cage 1 will be favorable outcomes upon total outcomes. Yes, favorable outcome upon total outcome. Dharshana is saying question it is given simultaneous. No. No. Simultaneous word is used in the question, I agree. But can you see when exactly it is used? Cage 1, so cage 1 to cage 2 simultaneously. That means 2 collectively go. And then after that, then can you see then 2 birds came back. So in the first round, there are 2 rounds happening. It is not happening that 2 birds are crossing. No. Can you see? 2 birds are going from here and there and sitting. Then second round, 2 birds are coming back. Understanding? Okay, I think the doubt is clear. Alright. Okay, so we have created how many cases? 3 cases. Okay. Case number 1, that from cage 1, 2 parrots went and 2 parrots came back. Okay, so the initial condition of cages will remain same as final condition of cages. Okay. Case number 2. 1 parrot, 1 owl flew from 1 to 2 and came back also the same. 1 parrot, 1 owl is coming back. Again, the cages condition will be same. Case number 3. 1 parrot, 1 owl from here to here, but while coming back, owl stays in cage number 2 and 2 parrots came back. So now that owl, after the third case, your owl is in cage number 2. Owl is in cage number 2. Now probability that owl is in cage number 1 will be favorable outcomes upon total outcomes. Correct? Alright. So now total outcomes, let me write over here. Total outcomes means summation of case 1, case 2 and case 3. Okay. So case number 1, what is happening? 2 parrots I need from cage number 1 and I need to send in cage number 2. So this is what? 5C2, 2 parrots. Okay. And now when 2 parrots went from cage 1 to cage 2, so now there are 8 parrots in cage 2. So 8C2. We want that 8C2 to come back also, right? So 5C2, 8C2 plus sign. Plus. What about this? Now I want 1 parrot, 1 owl from 1 to 2 and coming back also. So 1 parrot, 1 owl. So this is 5C1, 1 parrot from this and 1C1. Okay. Multiply. Now this is what? Cage 1 to cage 2. Now cage 2. When this is happening, cage 2 is having what? 6 parrots were already there. So 7 parrots and 1 owl. So I want same. So out of 7 parrots, I know I need 1 parrot and 1 owl, 1C1. Plus this time, can you see from 1 parrot, 1 owl? That means 5C1 one C1 coming back. So now if one parrot, one owl is on the right hand side, so it is having 7 parrots and 1 owl. What do you want back? You want 2 parrots back. 7 parrots. So 7C2. You don't want any owl to come back. Okay, this is your denominator. Numerator will be what? Owl is in cage 1. Okay, so owl is in cage 1. So can you see owl is in cage 1 in the case 1? Owl is in cage 1 in case 2. But in case 3, cage 1 is not having owl. Cage 2 is. So this case I am going to remove from favorable outcomes. So this is the third case. So this is 5C2, 8C2 plus 5C1 and 1C1 and 7C1 plus this is, that's it. Third case will not be there. Have I done this right? 2 parrots flew. So 6 plus 2, 8. And I want 2 parrots back. 5, 8, 40. This is how it is. Okay, so what is the correct answer? Tell me. So correct answer, ma'am, will be 5 8s are 40. Okay. So this is, sorry, 5C2. 5C2 is what? Can anybody tell me? Ma'am, 5C2 is 10 and 8C2 is 28. So this is 280 plus 35 upon this is what? Again 280 plus 35 plus 5 into 28. So 5 into 28 will be 105. 5 into, sorry, this is 7 and 6. 7 6 are 42. Sorry, this is 21. Yeah, 21 into 5. 21 into 5 is 105. So the correct answer will be what? Final answer, tell me. This is 315 by 420. That is going to give you 3 by 4. Okay, I know this question is a little bit confusing. Okay, so let me just tell you one thing. Now let me just tell you, summarize. Let me summarize. Okay, let's summarize from the beginning, top to bottom. Okay, so even with the event that 1 parrot and 1 owl flew from cage 1. E2 with the event that 2 parrots flew from cage number 1. Okay, and A be the event that owl is still in the cage number 1. Okay, now understand how this event A can happen. So there will be 3 cases. Case number 1, from cage 1, 1 parrot, 1 owl went, and then from cage 2, 1 parrot and 1 owl flew back. So this is your case number 1. Okay, this is your case number 1. 1 parrot, 1 owl going there, 1 parrot, 1 owl coming back. Case number 2, okay, 1 parrot and 1 owl going, but coming what? Coming is happening, 2 parrots are coming. Third, 1 parrot, third, 2 parrots going and 2 parrots coming. Okay, alright, so just understand these are the 3 cases. Now, cage number 1 was having what? 5 parrot, 1 owl. You want 1 parrot, 1 owl to go. So 1 parrot, that is 5C1. 1 owl, 1C1. This is cage number 1. Now, if 1 parrot, 1 owl you have sent to cage 2, what is the configuration of cage 2? Tell me. Ma'am, 6 parrots were already there. Now plus 1 parrot, 7 parrot, 1 owl. 7 parrot, 1 owl. So 7 parrot, 1 owl. Now you want 1 parrot, 1 owl out of it. So 7C1, 1C1. This is your case number 1. Similarly, think about case number 2 and case number 3. Correct? So now total favorable outcomes upon total outcomes. Correct? So what you don't want? Okay, so this case you don't want because 2 parrots are going and coming. Okay, so which case you don't want? Hold on. This case you don't want. This one. This one, because 1 parrot, 1 owl is going, but owl is not coming back. So how can it stay in cage number 1? Okay. All right. Perfect. Chalo. Now somebody is asking me, ma'am, why are you not using Bayes theorem? But yesterday I told you, how many of you were there in my session when I told you what is a Bayes theorem? So Bayes theorem may understand that you need to identify that this question will be done through Bayes theorem. Okay. So what is that identification? Yesterday session I told you. So see, the second part is the question of Bayes theorem. Why? First of all, understand. When two birds flew from cage 1 to cage 2 and two birds flew back from cage 2 to cage 1, the owl is still seen in cage 1. Can you see? Something has already happened. They are telling us. They are not asking us. Owl is still available in cage number 1. What is the probability that one parrot and the owl flew from cage 1 to cage 2? Okay, so this is actually a problem of Bayes theorem. No, this is actually a problem of, sorry, conditional probability. Not Bayes theorem. This is conditional probability. Conditional probability, which they are seeing. They are saying that probability that one parrot, one owl flew from cage 1 to cage 2, given that owl is still in cage 1. So how will you do this question, conditional probability? Okay, so this is how it is done. Oh yes, Bayes theorem, not conditional. Okay. Bayes theorem. So this is owl is still seen in cage 1. So something has already happened. No? Something has already happened. So Bayes theorem say, how will you do? How will you do from Bayes theorem? So you will write the total probability in the denominator. What is the total probability? You have just calculated it, by the way. The total probability of the events will be what? So this is the total probability. You have calculated the total probability only 315 upon 420. So total probability will be 315 upon 420. All the cases are concluded over here. What about the numerator? Numerator is one parrot, one owl flew from 1 to 2. So one parrot, one owl flew from 1 to 2. That means, see, case number 1, okay, and case number 2. 1 and 2. So 35 plus 280 will be the probability in the numerator. So 35 upon 420. So correct answer is what? 35 upon 305, 1 upon 9. Okay. Bharadwaj, you have to do this question through PNC only. Okay. You can't skip PNC. Acha chalo, enough about probability question. Shall we move on to the next question now? This is your case study based question number 3. This is third question. Okay. The traffic police has installed overspeed violation detection, OSVD, at various locations in a city. These cameras can capture a speeding vehicle from a distance of 300 meters and even function in the dark. Okay. Alright. So now let us read the overall case study. A camera is installed on a pole at a height of 5 meters. So there is this camera installed, okay, at a height of 5 meters. So this is your 5 meter height. It detects a car traveling away from the pole at a speed of 20 meters per second. So a car is coming, okay, in this direction, and what is happening? At any point, so it is x distance, as per the question it is x distance away, and this is the angle of elevation, okay, correct. This is the diagram. On the basis of this, give the following answer, okay. Find d theta by dx. So first of all, not the second question. Express theta in terms of height of the camera installed on the pole. Express theta in terms of height. So this is very easy, not tan theta is equals to 5 upon x. This is the first part. Can you see first part? Theta in terms of height of the camera and x. Tan theta is h upon x. First part clear? Okay. Okay, Kichu is saying, ma'am, did NTA collaborated with CBSE because these questions are literally cooking. I agree that cage wala question was a little bit tough, but this question is not that tough. This question I will assure you everybody will be answering. Second part is d theta by dx. So you just need to differentiate. So this is, how will you do that? First of all, theta is tan inverse 5 by x. So d theta by dx will be what? 1 upon 1 plus 5 by x square multiply minus 5 upon x square. Correct? So this is your d theta. Let me show you the solution. Okay, so d theta by dx is 1 upon 1 plus 5 by x whole square into minus 5 by x square. Okay, so d theta by dx will be what? X square upon x square plus 5 square minus 5 upon x square. Minus 5 upon x square plus 5 square. Okay, second. Alright, now the third part. Find the rate of change of angle of elevation with respect to time. That means they are talking about d theta by dt at an instant where car is 50 meter away from the pole. So d theta by dt at x equals to 50 is what they are asking. D theta by dt. So again theta value is what? Tell me. Tan inverse 5 by x. Theta value is tan inverse 5 by x. Correct? Now d theta by dt. So differentiating both the sides. D theta by dt is equals to differentiating this with respect to t. Okay, so derivative of this is what? With respect to x. 5 square plus x square. Okay, into dx by dt will be there. Correct or not? See, d theta by dt will be what? D theta with respect to dx and dx with respect to dt. Okay, so d theta by dt. This is what they want us to calculate. Okay. So now dx by dt. Now can you see speed is given as 20. Speed is given as 20. That means this is nothing but dx by dt is equals to 20 meter per second. Right? Remember, velocity, differentiation of distance with respect to time is what? Speed only. So just put the value. Okay. D theta by dx. So we have put the value into 20. This is what? Dx by dt. Just multiply it. So what you add, put x equals to 50 also over here. So if you put this is minus 100 upon 25 plus this is 250. Correct? 2500, sorry, yeah. 25, can you see minus 100 by 2525 is the answer. Minus 4 by 101. Now the unit of this d theta by dt will be what? Radian per second. So this is radian per second. Okay? Alright. Now B option of this thing, which is if the rate of change of an angle of elevation with respect to time is 3 by 101. Now what are they giving? They are giving something. Rate of change of angle, that means d theta with respect to time, okay, when x equals to 50, okay, is nothing but 3 upon 101. Then find speed of the car. Then find speed of the car. Understand? See, d theta, sorry, theta is equals to what? Tan inverse 5 by x. Now d theta by dt, you know, if you differentiate with respect to x, you are going to get minus 5 upon 5 square plus x square into dx by dt. Correct? Okay, now d theta by dt they are giving 3 upon 101. This is minus 5 upon 5 square plus x equals to 50. That is 2500 into dx by dt is what you are looking for. So you just need to calculate the value. So 3 into 2525 upon 101 into minus 5 is your dx by dt. This is your speed, my dear students. So yes, this is 5 ones are 5. 5 ones are 5. 101 cancel. So dx by dt is coming out as, can you see, 3. Oops, 5 was already there, right? So speed will be have I done anything wrong? See, this is 5 ones are 5. 5. This is 505, my dear students. Yes, 505. 505, right? So this is 5 only. So answer is dx by dt is what? 5. And understand, you have to write the unit also. This is what? Meter per second. Meter per second. Okay? 15 meter per second. With a negative sign. Clear? Correct? Alright. Next question, next question, next question, this question. Now this is again from probability, but relatively easy question from probability, okay? Relatively easy question from probability. According to recent research, air turbulence has increased in various regions around the world due to climate change. So what is happening? That plane is flying, but in the air there is air turbulence. How many of you have traveled with flight? How many of you have traveled with flights? So it happens now, we take a flight and we just take a flight and we just get late. Flight is delayed. There is an announcement from the captain when the captain says that air is turbulent, light turbulence we are finding, severe turbulence in the air, moderate turbulence in the air. Right? It happens, and that is why your flight gets delayed. You will stay in the air for longer time. Okay? So, turbulence makes flights bumpy and often delays in the flight. That we know. So, first half of the question is clear. Assume that an airplane observes severe turbulence, moderate turbulence or light turbulence with equal probability. Equal probability means that suppose you will be like, you are traveling to a flight. I'll come and ask you that what do you think? What is going to happen today? Do you feel light turbulence will be there or moderate or severe? You will be like 33.33% chances are there, equal probability. So, severe turbulence ki probability is 1/3, moderate also 1/3 and light turbulence is also probability 1/3 because equal probability. Further, the chance of an airplane reaching late to the destination are 55%, 37% and 17% due to severe, moderate and light turbulence respectively. And now on the basis of this data, find the probability that an airplane reached its destination late. So tell me, this is total probability theorem. TPT, total probability theorem, which says that probability that the flight reaches late will be nothing but what? So suppose, let me just write, how to write also. A is the event of flight being delayed. Okay. E1 is the event of flight getting delayed. E1 is the event that severe turbulence is getting formed. Severe. Okay, E2 will be what? E2 will be what? Moderate. Moderate turbulence. And E3 will be what? Light turbulence. Okay, so just tell me, in how many ways your flight can get late? So, flight can get late when you are facing severe turbulence and probability of delay happening because of severe turbulence. Then second thing is moderate turbulence is happening and probability of flight getting delayed because of moderate turbulence. Then light turbulence is happening, probability of flight getting delayed because of this turbulence. So now 1 by 3 answer will be what? 1 by 3 into, as per the question, 55% is happening because of severe. So 55 upon 100 plus 1 by 3. Now as per the question, 37 because of mild turbulence plus 1 by 3. As per the question, 17% because of light turbulence. So this is 17 plus 55 plus 37, that is 109 upon 100 into 1 by 3. So final answer will be 109 by 300. Correct? First part clear? Okay, everybody, I think you guys are clear. Now, I think these questions, I think cage wala question was a little bit, I also didn't like. If the airplane reached its destination late, now can anybody tell me that if this is total probability, the second part will be from which theorem? Second part will be which theorem? Second part, if the airplane reached its destination late, that means something has already happened. Okay, find the probability that it was due to moderate turbulence. Okay, find the probability that it was due to moderate turbulence. Okay, so Bayes theorem says that in the denominator you have to write the total probability. What is the total probability? 109 upon 300. Okay, in the numerator you just need to write the moderate favorable probability. Favorable probability is E2, which is just this one. So 1 by 3 into 17 by 100. Okay, this is the answer. 0, 0, 0, 0, 3, 3. 17 by 109. Not the 17 one, right? Moderate is what? Huh? Moderate is 17. What is the moderate configuration? 37, sorry students. Moderate is 37. Okay. 37, 37. Here also moderate is 37, right? This is the third one. This is the moderate one. Sorry. Moderate is 37. Correct? 37 is correct. 37 by 109. Easy question. What do you think? Next, case study number 4. Okay. Ma'am, how will be the paper? Tough or moderate? Moderate paper. Moderate paper. I think easy to moderate. Obviously in mathematics, I think 60% of the paper will be easy. 50 to 60% of the paper will be easy. Then 20 to 30% will be moderate. 10% you will get 1 or 2 questions which will irritate you. Okay, be prepared. The government declared that farmers can get 300 rupees. But can you see? So 10% of the paper, if I am saying that, so 8 marks approximately. So 73, 74, I think everybody can score easily out of 80. That 6, 7 marks you will only get when you spend some good time in that question. Okay? No, it will not be like physics. That's what my prediction is, and I don't know, I have that feeling. Ninja ma'am has some feeling and it always gets true. The government declares that farmers can get 300 rupees per quintal. You know what is quintal? Quintal means 100 kg. So 300 rupees per quintal for their onion. Okay. On 1st July. So what is happening? There is a season. So on 1st July, if they sell their onions to government, they will get 300 per quintal. But after that, on 2nd July, if after one day, the prices will be dropped by 3 rupees. That means 297 in the second day. And then 293 on the third day and so on. Okay. And price will also be, so price will be reduced. Correct? Okay. So yes. Shyam's father has 80 quintal of onion in the field on 1st July. Okay, and he estimates that crop is increasing at a rate of 1 quintal per day. Okay, so 1st July pe he is having 80 quintal. On 2nd July, he will be having 81. Okay, on 3rd July, 82 and so on. Just like that. Now, what are the questions? If X is the number of days after 1st July, then the price and quantity of onion. So, price of onion is 300. Okay. Now, after X days, what is happening? Price is dropping. Price dropping rupees 3 per day. Rupees 3 per day. For one day 3 rupees. For X day, price dropping is 3x. So total price will be 300 minus 3x. Okay, this is what your price is for X days, after X days. What about that quantity of onion? So quantity is, initially quantity is 80 kg. Okay, now every day quantity is increasing, my dear students. See, as per the question, 80 quintal, but it is increasing at a rate of 1 quintal per day. So it is increasing, so you need to add 80 plus 1 into x. Okay, if 1 day to 1 quintal, 2 day 2 quintal, 3 day 3 quintal, x days x quintal. So this is the quantity. Option A clearly seems to be the correct answer. Everybody, yes, getting it? Okay. See, x be the number of extra days after 1st July. So price is 300 into 300 minus 3x. And similarly, quantity 80 quintal plus x, 1 quintal per day. So 80 plus x. Correct? Alright. Reduce the brightness, you are saying. Why are you saying reduce brightness? I mean, you guys are controlling my studio. Okay. Now, as per the question, revenue R as a function of x can be represented as revenue. Revenue means that how much money that person is making. Okay. So just understand, we have calculated price. Okay. Price was what? 300 minus 3x for x days. And quantity, this is per quintal. And quantity will be what? 80 plus x quintal. Okay. Now just tell me, what do you do? If I just ask you, very easy question. You have price of 1 pen is 5 rupees and you have 10 pens. Now quantity is 10. What is the price of overall revenue if you sell it? So ma'am, 10 pens, 1 pen is 5 rupees. So 5 into 10, 50. So you just need to multiply these two functions together, right? If you multiply, you will get 24,000 plus. Okay, minus 3x square plus 24,000 and you're going to get, okay. So if you multiply these two together, tell me na. Yes, 80 plus x multiply 300 minus 3x is this, which is matching with option B. Okay, option B. Have a look. Okay. Alright. Okay. Again, number of likes of the session is not matching with live watching. Okay. Okay, it's greater today. But anyway, I want 200 likes on this session. Okay. Chalo, let's talk about this, which is maximum revenue. maximum revenue. Now again application of derivatives, maximum value. So first of all tell me that revenue is what? We calculated a revenue, right? That is 24,000. Okay, plus 6x minus 3x square. So r dash x is equals to 0 plus 6 minus 6x. Okay. Alright. R dash x is equals to 0 will give you x equals to 1. Now r double dash x is what, ma'am? Minus 6, which is less than 0. That means local maxima. So maximum value is at x equals to 1. So r of 1 will be the maximum value, which is 2400 plus 6 minus 3. 2400. Huh? Sorry, this is 60x, right? 60x. So 60, yes, this is 60. So this is again minus 6, yes. So 60 was there, correct? Now just tell me, if you put 1, so 24000 plus 60 minus 3. So from here x is equals to 10. Yeah, that's correct. Now put, so this is 2400. This is, if you put x equals to 10, you will get 600 minus 300, so plus 300. So 24300. Option C. Okay. All right. Okay. And now one case study based question I am giving you as homework. Okay, so this is two case study based question homework. One is from 3D geometry. So this is from 3D geometry. Okay, I am gonna give you a brief. This is line number 1. This is line number 2. Okay, so I am just skipping the case study based paragraph because there is no need in some questions. No need to read. See, in probability, in application of derivatives, you can read the paragraph. But in such questions, see, lines are given. Are the lines are coplanar? Justify your answer. Find the point of intersection of line 1 and line 2. So, what is the condition of coplanarity of line 1 and line 2? So, this is, remember the shortest distance between two lines. The numerator part of shortest distance between two skew lines should be 0. Hence, L1 and L2 are coplanar. Okay. The second point is, when the lines are coplanar, they will intersect each other, correct? Then you are having, can you see, this is what it is. So what you need to do is, you just assume one point on the line. Okay, let me just tell you. Here only, here. See, assume first point on the line. So this is 3 lambda minus 1, comma minus 2 lambda plus 3, comma minus lambda minus 2. What about this? Mu minus mu. 3 mu plus 7 minus 2 mu minus 7. Okay. So this and this equal. This and this equal. This and this equal. Correct? Okay. If you equate this and this, your lambda is going to be, I remember the value of lambda. Lambda is coming out as 1. The moment your lambda is 1, your point will be what? 2, 1, minus 4. This is the point of intersection. Okay, this is the homework question for you guys. And now one more question, case study based question. You can see again something they are giving, but they are giving something which is like not required to read. This is just the basic question from continuity differentiability. Fx is given. Then they are asking what is happening at x equals to 0. We can plot the graph also, right? So this is your graph function. Let's plot y is equals to x. For x less than or equals to 0, this is the line, and sorry, y is equals to x will look like this, and x equals to y is equals to 0 for positive x. So this is your thing. Can you see the graph is continuous, but can you see there is a sharp corner? So it is continuous but non-differentiable. Very clearly we can say. Okay. This is the last question. Okay. C option correct. Now the next part. Fx is equals to mod x minus 1. I have told you this. We have done this question, right? Case study hai, but again there is no need for doing this case study thing. So this, again modulus function are continuous but non-differentiable at this critical point. This is the critical point only. So non-differentiable. Continuous but non-differentiable. Option B. Alright. Then we are having this. Fx is equals to x cube. Cubic function, polynomial function are continuous and differentiable. So continuous and differentiable. Just fact-based questions. Fact-based questions. Option B. This polynomial functions are continuous as well as differentiable. Now fx is equals to GIF of sin x, greatest integer function. We know that greatest integer functions are discontinuous at... Okay, chalo. Let's do one thing. As per the question, they are talking about x equals to 0. Every option is all about x equals to 0 except the D option. So let us give priority to A, B and C first. Let's check what is happening at x equals to 0. So just tell me that f of 0 will be what? Sine of 0. 0 ma'am. F of 0 plus will be sine 0 plus. This is also 0. Okay. Sine of 0 plus will be 0. F of 0 minus sine of 0 minus. Sine of 0 minus will be what? So sine of negative angle. Can you see sine of negative angle is a negative fraction. Negative fraction GIF will be what? Minus 1. So this function is discontinuous at x equals to 0. If it is discontinuous, obviously it is non-differentiable. That is why nobody is talking about differentiability. Okay. Alright. And the last part of this question, which is sine inverse x. Sine inverse x. Okay. So this function sine inverse x, have you seen the graph of sine inverse x? Graph of sine inverse x looks like this. This is the graph of sine inverse x. 0, pi by 2, minus pi by 2. So this looks like a continuous function from, minus 1 to 1. Yes or no? If they are talking about minus 1 to 1, they are continuous. So it is continuous and differentiable as well. Differentiable as well, no? This function is continuous and differentiable within this. There is no sharp corner, there is no break point. Okay. Alright. Clear? GOWD bacha, how are you doing it with graph? So yesterday, first session I have taken continuity and differentiability, where the graph says that where graphically, if a function is having any break point, can you see there is no break point? This is so smooth. The function is so smooth. You have not lifted your pen. So that is why it is continuous. And whenever you see sharp corner says that yes, that function is non-differentiable. There is no sharp corner. So case study based question done and dusted. I'll share the PDF with you right away. This though will share in, what do we say? This we are going to share in Telegram directly. Very small file I have. Okay. Alright. Do more case study based question. Let's do one thing, bacho. I will share a PDF having more case study based question. Okay. So I'll share more important, like 5 case study based question I will add in this PDF and then I'll share. What do you think? Okay. So till now we are going to take a leave and I'm gonna see you in the next video, which is all about matrices, determinant, relation function ITF and differential equation and area also we are going to cover. Okay. So this is me, your